opened your bag that looks like this, then you should have taken out all your materials and you will see that you have 2 cups just like this, 2 packets of hot cocoa that hopefully you didn't just throw on the floor like I just did. Luckily it wasn't open yet. It slipped out of my hand. So 2 cups, 2 packets of hot cocoa, a mini bag of marshmallows, and a spoon. You will need access to water and a microwave to do this experiment. So the first thing we're going to do is we are going to talk about matter because we need to know what matter is before we start this. So Dorian, if you don't mind, can you tell me what matter is? You can
I don't know how to explain it.
Can you give me an example?
Yeah, solid, liquid, and gases.
Those are all forms of matter. So matter is basically anything that takes up space. So you can fill that in on your sheet that it's anything that takes up space. And Dorian just gave us the great examples of either solids, liquids, or gases. On your sheet is thermal energy, which is heat energy. All of my 3rd graders should know that because we're doing energy lessons right now in class. And it's basically where it's moving and transferring from one thing to another. Like when you rub your hands together, you feel that heat and that friction, and that's a form of thermal energy because we feel that heat. Dorian, are you able to explain to me what temperature is?
Yeah, so like something cold or something hot.
Simple enough. How hot or how cold something is. We're going to go with that definition. And then one word that we probably have not learned yet in any of my classes is called a colloid, which is basically a mixture with very small particles that are evenly scattered throughout. So if you look on your sheet right here that you should have, your little sheet that we're doing with our experiment, it has this picture of those solid liquids and gases and how the thermal energy is going from one way to another and how matter can change. So we're going to make some predictions here and we're going to write a hypothesis. So there's 2 questions to write a hypothesis to. The first one is which cup of hot cocoa is going to have it dissolve faster, because we are going to make these cups filled with warm water and hot water. So which one do you think is going to dissolve the fastest? And you can write your hypothesis under number 1. So Dorian, you can write your hypothesis and you can tell me if you would like.
Probably the hot cup.
And then the second question, once we have done that first part of the experiment, we are going to then use these mini marshmallows to see which one will fully dissolve the fastest, and this is going to make it a colloid. So about how long do you think it's going to take to dissolve in both the warm cup and the hot cup, and which one do you think will be faster? You can write those predictions down in number 2 for your hypothesis. So Dorian, which one do you think is going to dissolve the fastest, the warm or the hot cup?
Probably the hot one.
Okay, and about how long do you think this is going to take?
A minute, maybe a minute and a half.
For the hot one?
Yeah, for the hot one.
Okay, and then how long do you think it would take maybe for the warm one?
2 minutes.
Okay, so a little bit longer. Okay, so now we're going to start the actual experiment now that we have our prediction of what we're going to do. So you're going to fill the cup. It says for a cup of water, but we don't want to get it too full to the top because we want to make sure we have room to put the marshmallow and the hot cocoa powder in there. So I would say fill it a little bit more than halfway. So if you're not near where you can get water, then you can move over to get the water. Or if you have a measuring cup, you can use that as well, like I have over here. I only did it for 1 cup though, and then you'll have to do it for the second one as well. And what you're going to now do, sorry, had to get more water. You're going to fill both cups up and you're going to put in one at a time in the microwave. So you will need a parent with you to make sure that we are putting these in the microwave safely. And you're going to put the first one in for only about 30 seconds. And you're going to test to make sure it's warm water. Make sure that you're not sticking your own fingers in the cup and let your parent test it for you. So I'm going to put mine in my microwave for 30 seconds. And then once you've done that and we take it out and make sure that it's actually warm, then we'll put the other cup in for about 75 seconds. So a little bit more than a minute, just to make sure it's definitely hotter than the other one. And then you can always do it a little bit longer if you need to, if it's not warm enough or not hot enough, but let your parents test it. Don't put your fingers in the cup, please. We don't want to burn anybody's fingers. You just tell from the outside, this is a little bit warm, so that's good. My 30 seconds was good, so now we're going to do the 75. Okay, so while that's doing that, I'm going to start getting my hot cocoa ready. I'm not going to put it in yet, so I have both at the same time so that I can make sure that it's at the same time. But I am going to open up my hot cocoa packet so it's ready as soon as the other one gets out. And I can mix them in. And if you do not have a timer near you, you can always use your iPad as a timer or your phone. And it'll kind of tell you the time when we get to the timer part for our marshmallows. Because we don't need to time it for the hot cocoa. You can kind of just stir and observe, but that way you're all ready for all parts of our experiment. 75 seconds feels like a long time right now. But we'll see. Oh yeah, that's steaming, so that is definitely hot enough in that cup. So what we're going to do is once I have them both out of the microwave, Dorian, did you do yours in the microwave yet?
The 75-second one's still in the microwave.
Okay. All right, I can wait till you're done. Let me know when you're done and I'll do the next part. Yep, I got some more people telling me they can't get in. Well, that's okay. They'll get the video later.
Set in the microwave.
Okay, perfect. So once you're both out of the microwave, carefully, you're going to take each packet of hot cocoa and pour it into your cups and use the spoon to kind of stir it a little bit just so it starts to dissolve. And then you're just going to kind of watch and observe which one dissolved the fastest. I'm putting it in my warm cup first and then my hot cup. I'm just going to let it sit for a second. Ooh, this smells good. You have hot cocoa in front of you, it's going to smell good. All right, I'm going to bring these a little closer so we can see. All right. So this is my warm cup, and it's still pretty clunky as I'm stirring it. And my hot cup. Dorian, what do you see with your hot cup and your warm cup?
The hot cup is steaming, and it's dissolving the hot chocolate faster.
It is definitely dissolving that hot faster. It was like lightning fast in mine, and the warm cup is still a little clunky. Like I'm keeping on having it, stirring it, and it's taken a little while to dissolve. That hot cup is definitely fully dissolved. I can't really tilt it so we can see. Maybe I can. Let's see. Can you see it in there? Not really. Okay, we tried. It's all right. You have it in front of you. You're seeing what I'm seeing. So it's okay. So we definitely know that your hypothesis was right, that the hot cup used that thermal energy to dissolve that a lot quicker. And now what you're going to do is you're going to take your marshmallows that I already put over there, and you are going to just put it in there. You can put just one just to see. You can use the others later and see which one is dissolving. You're going to also set your timer so you can see how long it takes. So I'm setting my timer, and you can use those spoons to kind of get it all soaked in there so we can make sure it's getting all of that thermal energy in there so that that heat transfer is happening so we can see how long it takes. While you're doing this, you can also fill in the data chart. So Dorian already answered for us the first part, that the warm cup dissolved slow and the hot cup dissolved very fast. And then time marshmallow dissolved is going to probably be a little bit different for everybody since everybody is doing this in their own microwave in their own home and everybody doing it differently. So that's why you need your own timer, but I can already probably tell you, Dorian, which one did you say was going to dissolve the fastest? The hot one or
The hot one.
Yeah. Are you thinking that's correct? Did you already put your marshmallow in?
Yeah, it's definitely kind of. Yeah, it's very liquidy. Very.
Yeah, I can tell you right now at about 1 minute, 10 seconds that mine is almost all completely dissolved. Oh no, I know.
There's only little pieces of it left now.
Yep, just very tiny pieces, and mine is actually completely dissolved now at 1 minute and 24 seconds. So if I were doing my sheet, I would put hot 1:24, but I'm going to keep the timer going because it's not yet dissolved in the warm cup. I will say honestly, if you're doing it with the warm cup, it might take even longer than the time we have on here. So I'm probably not going to end up putting that time in here, but that's okay. This is for you to drink and enjoy after we're done and we write what we learned. So because my marshmallow, I don't know here if I can do it so we can see it's pretty much not dissolved almost at all in the warm cup. So it might take like, you know, a couple 10 to 20 minutes till that actually dissolves. So you can still keep your timer going, Dorian, if you would like to do that. And everyone who's going to do it at home can keep their timer going until it actually fully dissolves. But we're going to probably end in another minute. So what do you think you learned from this experiment, Dorian?
That the hotter something is, the faster it's going to dissolve stuff.
Of course, that heat transfer, that thermal energy is going to transfer into that object and make it dissolve faster. So in things like a colloid, which our hot chocolate is, where it's dissolving the pieces, and the marshmallow, when it's fully dissolved, is doing that, it's going to take that heat on to then fully dissolve. And the hotter it is, that the quicker that's going to happen. So thank you, Dorian, for summing that up for us. I'm very sorry for my friends who were not able to log in with our technical difficulties, but you're going to still be able to have this experiment at home and enjoy your hot cocoa. So we're going to end the meeting. Miss Burdick, is that good? We're good with that? Oh, you're muted.
It was a great, there was a delay there. It was a great activity. Thank you, Ms. Vargas.
All right, thank you. And thank you, Dorian, for logging in and participating with us. Everybody else is going to be able to hear what you learned, and hopefully they learn the same thing. And enjoy your hot cocoa, okay?
Okay.